Hello and welcome to my Lab 5 for Modern Physics 1. In this lab I explored how starting height and the angle of a rope affects the motion of a jump from a rope swing. I also found that the higher you start, you're going to go further. And I found the optimal angle for this distance is around 30 to 35 degrees. We modeled it using Newton's second law and the force of a spring, which we used to model how our rope pulled on the jumper. These equations are the forces that we use. We have the force of gravity, which is simply negative the mass times gravity times a j-hat vector that gives it our direction. And our force of the spring is our negative the spring constant. This is our how far the rope is stretched, and this is the L-hat vector to give it direction. We use Newton's second law, which starts out with delta P equal to F net delta T, and when you derive it through all this, we get V final, which equals V initial, plus F net over M times delta T. We also use our position update formula, which you can see here. Position final equals position initial plus velocity times delta T. We do make some certain assumptions in this lab. For example, we're not taking air resistance into account. We're assuming there's no friction at the pivot point. We're also assuming our rope has very little springiness. It doesn't stretch much at all. And here's our code that models this. This is our person's mass in kilograms. This is their starting height, around 18 meters above the water in this example. This gives it our position and velocity, which is 0, of course. This is also our delta T. Our gravity is 9.8, of course, and our spring constant is set very high. This is around 1,000,000, to show that the rope doesn't stretch much at all. It's very stiff. The L gives it our length and position. The LO, the relaxed length, is equal to the magnitude of L. We're assuming that the rope is already started at its relaxed length. They weren't starting at less than or greater than that. And we use this to keep track of our maximum height throughout the jump. This is our first loop that we use. This calculates our force of gravity and our force of the rope, which are just our previous equations in code form. The F net is just adding those together. Here's our Newton's second law and position update formula. These just update how the rope changes its motion, its stretchiness, and all that. Now this checks the difference in the angle between our rope vector and a vector that is going horizontally to the right for our simulation. And when it gets within 55 degrees of that, the x-axis loop and the person jumps. This is our second loop that models them jumping. It's just like our first loop, except there's no force of spring at all because he's not holding onto the rope anymore. We have all of our previous equations. F net is only F gravity at this point. They keep their velocity, so we just change their velocity with only the force now. This keeps track of the person's maximum height. This ends the simulation when the person hits the water. After we ran all the simulations, I put the data into Excel and got some nice graphs out of it. This models the height and the distance as the starting height changed. I went 0.5 increments in meters, and this is black line is our distance, and the blue line is our maximum height. As you can see, our distance was probably more effective, so it's got a greater slope, while our maximum height was a bit more stable and increased only slightly as you increased the initial height. All of these jumps were also taken from the 45-degree angle mark. I just didn't change the angle at all, and so these are going to be a constant angle. This is when the starting height was kept equal, set at exactly 18 meters above the water, and the angle changed. This is starting from 0 all the way to 90 degrees. As you can see, when he started at 0, not that much height or distance, which increased greatly as there was more height and more distance. And as you can see, around after 30 to 35 degrees, the distance traveled, the black line still, actually started to decrease as most of the velocity was directed upwards and not outwards. Our maximum height always increases, interestingly enough, no matter how long you hold on to the rope. though it's probably best to release somewhere in the 35 to 40 degree mark to get maximum distance as well as maximum height. And our conclusion. So based on that, we can probably say that rope swings are most fun when you're starting from a large initial height. You probably want to be as close to the anchor point as possible with your initial height. Higher might lead to the rope kind of stretching more, maybe losing some energy through bouncing around. It's best to release the rope at roughly 35 degrees for maximum height and maximum distance. And you also probably want to make sure that you have something soft to land on. In my models, my jumper landed with approximately 17 meters per second of velocity, which would be quite painful if you were landing on hard ground. Thanks for watching.